we need to obtain the value of derivative of y with respect to x whenever x and y are given in its parametric form. That means x and y are both dependent on the parameter t. So let's begin with whatever we're provided with. So here we have x equals to cosine inverse of 1 divided by square root of 1 plus t squared. Fine. And we have y given by sine inverse of t divided by square root of 1 plus t squared. Right. Now what we have to do is take the derivative of x with respect to t as well as derivative of y with respect to t. But before that, what we'll do, we'll try to simplify the expression on the right hand side of x as well as y so that we can easily take its derivative. To do that, all we have to do is make a substitution. We're going to consider t to be equals to tangent of theta. So when you take t to be equals to tangent of theta, then square root of 1 plus t squared. So this will be equals to square root of 1 plus tangent squared theta. We know that 1 plus tangent squared theta, this is a trig identity, secant squared theta, and we have the square root, so that means we have secant of theta. That means x becomes equals to cosine inverse of 1 over secant of theta. Now secant of theta, that's actually the reciprocal of the cosine function. So that means we have x equals to cosine inverse of cosine of theta, which gives us x equals to cosine inverse of cosine of theta will be simply equals to theta. Now since we took theta to be t to be equals to tangent of theta, this would mean that theta must be equals to inverse tangent of t. So that means we have theta, in place of theta we have tangent inverse of t. Meaning we started out with x equals to cosine inverse of 1 over square root of 1 plus t squared. So when we make this particular substitution, t equals to tangent of theta, then x becomes equals to tangent inverse of t. So let's label this as equation number 1. Now going back to y, so we'll take the same root. So we're going to consider t to be equals to, since we took tangent of theta, we are going to take tangent of phi. The tangent of phi means we have square root of 1 plus t squared. So this will be simply equals to secant of phi. Now we have y equals to sine inverse of, so here we have t in the numerator. So t is tangent of phi. This is divided by secant of phi. Now we know that tangent of phi over secant of phi, that's actually the sine function. So we have sine inverse of sine phi. So sine inverse of sine phi means we simply have phi. We started out with t equals to tangent of phi. So that means y must be equals to tangent inverse of t. So let this be equation number 2. Now our task will be to find out derivative of x with respect to t, which is simply equals to derivative with respect to t of the inverse tangent function. Now that's a standard formula, which is square root of 1 over 1 plus x squared. Similarly, we take derivative of y with respect to t, since we have a tangent inverse function. So this will be 1 divided by 1 plus x squared. Now we can finally find out derivative of y with respect to x. All we have to do is take derivative of y with respect to t and divide it by derivative of x with respect to t. So this will be equals to 1. So that means we have successfully found out the value of derivative of y with respect to x.